Okay, here's your notes for section 5.1. Watch them, pause it when you need to pause it, and get them all written down before you can do your assignment. We're talking about inequalities. We've already talked about inequalities, less than, greater than, less than or equal to, but we're going to graph them on a number line. In the past, you've only set them up, did a little solving with them. When you graph on a number line, you're either going to use an open circle or a filled in or closed circle. Open dot, closed dot, we call them both. How do you know when you're going to use an open circle on your number line or a closed? The open circle is going to use either a less than sign or a greater than sign. Remember, less points to the left. Less is left. Or you can make an L with your finger and close it and make a less than sign. That's greater than sign. Just a friendly reminder from earlier in the year. When do you use a closed circle? Some of you maybe have already guessed. A closed dot is when you still have a less than, but now it's less than or equal to. Greater than or equal to. It can be equal to also. The closed dot says, yes, use that point, use that number. The open dot says, get as close as you possibly can to the number. So let's say we're approaching 2, but you can't actually use 2. You can use 1.9999999, but you can't use 2. This says less than, you can use 1.99999, and you can use the number 2. That's the filled in dot. Okay, so we're going to start with ones that don't need to be solved. They're already set up. Notice I have a variable here, x. We can't use the alligator anymore like you did in elementary school for talking about the alligator mouth eats the bigger number because we don't know what x is. So to help everybody be the same, uniform, do it all exactly as is, we will always put whatever the variable is first. That variable x is going to be written first in the inequality. And then this is less than 3. Okay, x is less than 3. So we make a number line. You need at least 3 or 4 points on the number line to get your bearings. So we'll go with 1, 2, 3, 4. Back to the previous page, you're going to use an open circle. And x is less than 3. Which numbers are less than 3? 2 is, 1 is, 0 is. We just keep going. You must draw an arrowhead on here to show that it's going to continue on all the way to negative infinity. It will continue on and on and on. Let me show you a cool trick. If you did this correctly and you pointed it the right way, I know that there's struggles with which is less, which is greater than, which one points which way. Check this out. This is an arrow. It's a less than arrow. That less than arrow, if you copy it, will go in the same direction as your arrow on your number line. If you have it over here, you're going the wrong way. So your less than points to the left, and those two match. That only works if you set it up and put your variable, x, y, z, whatever your variable is, has to come first in the inequality. If the variable doesn't come first, then we have a mixed match, and those don't match. Let's try another one. X is greater than or equal to negative 1. Be careful on your number line. You have to make a number line that goes in the correct order. Think of it like a thermometer that got turned sideways. If this is 0, this is warmer, 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 this is colder, 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 you would go with negative 1, negative 2, negative 3. These numbers are getting smaller going that way. This time we have an underline, closed dot over the negative 1. And it reads, with the variable first, x is greater than or equal to negative 1. Greater than or equal to. What's greater than or equal to negative 1? 0 is. If you want to put another one, 1 is. 2, 3, 4, 5, 6. And again, check and see if it matches. Greater than points to the right, but it also matches your greater than sign. The arrow and your greater than sign. Next page. This one is asking you to write an inequality. I'll give you a second. If you need to pause this, go ahead and draw what I have there. Okay, we have to write an inequality. We're working these problems backwards. They're giving us the graph. We have to make an inequality. If they gave us this graph, we would have to make an inequality. They gave us this diagram. Couple things. We already stated you will always start with a variable. I picked x. You can pick a different variable if you'd like. I picked x. You recognize that it's an open circle, so there will not be an underline under it. We're either going to go less than or greater than. Where is that open circle? It's right above the 9. So that's the number that we're talking about. Find the circle, find the number. Write those down first. Now we need to decide, are the numbers getting less or are the numbers getting bigger? Let's check. 9, 8, 7, 6. They are getting less than. All of the numbers x are less than 9. And again, go ahead and check. Easiest way to check. It'd be cool if you could drag an arrow like this on your notebook paper, which you can't. But if you draw that the correct way, your arrows will match. X is less than 9. Says write an inequality. There's our inequality. Let's try another one. You write this one. Go ahead, pause, write it down, pause it, think about it, write your answer, and then check it with mine. Okay, hopefully you paused it, took care of it. Now we check. Did you get the same thing? I'm using the variable x. I'm going to go with the number here. Halfway between -2 and -3, which is -2.5, or -2.5 if you chose to go with a fraction. It does have a closed circle, so I'm going underline. And all of the numbers are getting bigger. -2 is bigger, -1, 0, 1, 2. They keep getting bigger and bigger and bigger, which is an arrow going to the right. X is greater than or equal to -2.5. We'll check again with the red arrow. Greater than, greater than. Solid dot, solid underline. All of the numbers x are bigger than -2.5. That one was a little tougher because of the decimal, but you can handle it. Solve this inequality first, then graph it. Take a moment to write down the instructions, draw the number line, and write the problem. Pause it, and we'll be back. Okay, you're back. We have to get x by itself. Solve. Solve meaning isolate the variable. Add 5 to both sides. Adding 5 will cancel this. We have an x. Keep the sign. And -4 plus 5 is 1. We actually treated that inequality just like it was an equality. If that's an equal sign, you do the same thing. The only difference is when you have an answer, now that you have an answer, it has to be graphed. We never had to graph an equal sign. We want numbers that are bigger than 1. Let's throw a few numbers on the number line. 0, 1, 2, 3, 4. We're going to start with 1. Recognize that there is not an underline, so we won't close our circle. And the number that we're working with is 1. We want it to go greater than 1. What numbers are greater than 1? 2 is, 3 is, 4 is, 5 is, 6, 7, 8, to infinity. Keep going. Check your answer. Does it match? Greater than, greater than. So solve the inequality. Here's your answer for solve the inequality. And graph. There's your answer for graphing. 2 parts to every problem. Try this one on your own. See if you get what I got. Okay? Pause it and come back. You're back, checking to see if this is the same process that you did. You're just checking to see if you did it right. You could have different numbers on the number line than I do. Maybe they're not quite the same, but they have to have the number 12 involved. You have to have a closed circle, and the arrow is going to the left, matching the less than sign. Again, maybe you put 10, 11, 12, 13. Maybe you had 9, 10, 11, 12. It's okay as long as the number 12 is included. Try one more on your own as a decimal. Pause it, write it, solve it, graph it, come back. And you're back. -9.5. Be careful with your subtraction. Hopefully use the calculator. If you take 9.5 and minus 5 from it, you will get a -4.5. Be very careful with your graphing. Students have a tendency to go, oh, here's -4, so this must be -4.5. Remember, you're counting negative. -1, -2, -3, -4, -4.5. Open circle, arrow goes to the left. Check and see if that's what you had when you pause the video. If not, change it, fix it. Put a note by it and recognize what you did wrong. This one's a little trickier, so we'll do this one together. Notice the X is on the other side of the inequality. That's okay. We've solved them like that with equal signs. I'll go to the other side of the board. We're on the other side of the inequality. I'm still going to get X isolated. We need to get the variable by itself. Subtract 7, you get 2 is greater than or equal to X. The problem is we can't graph that. We can, but it would be very confusing. What you want to do is rearrange, because on all of the other problems we talked about that X has to be first. You can't, the graph won't match up with the greater than sign unless we put the X first. So it should be written as X is less than or equal to 2. Notice I took the whole entire thing and flipped it all reflected. The X comes first. This still points to the X. If you're looking at it as an alligator, it still points to the X. X is less than or equal to 2. Now it's easy to graph. Now it matches all our other ones. Throw some numbers on the number line, use a closed circle over the 2, and go to the left. If you're confused on that, rewind and go back and watch some of the other ones. At any point, you can pause, rewind, rewatch any part of these notes to slow it down. Last one is a word problem, and yes, I want you to either write down the whole entire word problem or write down what you think are the key pieces and the information. You don't have to draw the picture. But if you can, that'd be cool. I'd like to see your artwork. You're checking a bag in an airport. Bags can weigh no more than 50 pounds. Write down all the important information. Your bag weighs 16.8 pounds. Write an inequality. Write an inequality. So we're going to have to write something that looks like this that we're going to have to solve. Write an inequality and then solve to find the possible weights you can add to the bag. We know we're going to write an inequality, so we're going to work with X's. We know that our bag can weigh no more than 50 pounds, so 50 is our target. 50 is our solution. Our bag already weighs 16.8 pounds. We've already weighed it. We have 16.8 pounds. We want to go shopping at the airport and add some more weight to it. If we add more weight to this, it said it cannot weigh more than, no more than. You have to ask yourself, can it be exactly 50 pounds? Weighs no more than 50 pounds. Yeah, it can be exactly 50 pounds, so it could equal. But then it needs to be less than that. Every time your poundage goes over 50, you have to pay more money. 16.8 plus whatever you're going to add when you go shopping, little souvenirs or something, a couple snacks you're going to take with, has to be less than or equal to 50. Write an inequality. It says, then solve it. You need both answers. You have to have this on your paper. Then solve it. If you minus 16.8 from both sides, you get X. Which is less than or equal to? Take 50 minus 16.8, and you should get 33.2. 33.2. What does that mean? X is less than 33.2. Write an inequality and then solve to find the possible weights you can add to the bag, and we're talking pounds. Make sure this is realistic. If you solved it properly, it says that you can add, and let's go with some English instead of some math. You can add up to 33.2 pounds. You can add up to 33.2 pounds. Or you can add no more than. You can use the words that they used. No more than 33.2 pounds. All right, this concludes your notes. And when they're finished, you'll, of course, show, Mrs. Bester, show me that you have them done. I'll look them over and check for accuracy, and then you will be allowed to start your assignment. Use these notes to help you with your assignment and your daily quizzes. I'm over here. Notes, daily quizzes, and double check them for accuracy. Rewind the tape, pause it, redo it anytime you need to. I'm out.